You voted for it? Now let's build it. The Great Big Quiz of Everything came #1 in our user poll in the NAC app. And when we say everything, we mean it. This ain't any old quiz app. It's the ultimate trivia showdown with dynamically generated questions on everything, from pop culture to the mating habits of the Patagonian toothfish. There's no topic our app won't spin into a lightning round. This video is part 1 of a 4-part series where we push FlutterFlow to its limits. Today, we're setting the stage by configuring Supabase for rock-solid database and authentication, and building a flashy, podium-ready UI using reusable FlutterFlow components and libraries. Get these foundations right, and you'll be all set for the AI magic in part 2. You can access everything we build today in NAC, available now on the App Store and Play Store. It's your go-to micro-learning platform for all things FlutterFlow. Plus vote on what we build next in this series. Links in the description below, or scan the QR code on screen now. All right, it's time to peek behind the curtain. How is our quiz actually going to work? While it's tempting to jump straight into FlutterFlow and start building those flashy app screens, pausing for a quick strategy huddle is key. We need to decide on our backend dream team. Think of FlutterFlow as our dazzling game show studio. It handles everything the audience, our users, see and interact with beautifully. But for the complex stuff happening backstage, managing contestant scores, generating unique questions, even queuing up our AI host, we need dedicated specialists. Why? Because sending heavy processing tasks to a backend keeps the main stage, the user's app, snappy, responsive, and prevents it from getting bogged down. No one likes a laggy game show. For this quiz, our all-star backend crew features Supabase. This is our secure vault and database. It'll handle all player authentication and store every crucial piece of data in its database. And BuildShip. This is our hyper-efficient control room and logic processor. It takes instructions from FlutterFlow and orchestrates the complex tasks. So here's the typical flow. The player hits Start Quiz in our FlutterFlow app. FlutterFlow sends an API call to BuildShip. BuildShip processes the request, which might involve chatting with Supabase to fetch or save player progress, coordinating dynamic questions with OpenAI, or queuing up our 11 Labs voice host for commentary. Once BuildShip's finished calculating everything, it sends only the essential results back to FlutterFlow. FlutterFlow updates the UI instantly with the fresh data. This division of labor means FlutterFlow focuses on delivering that slick, smooth user experience, while Supabase and BuildShip handle the heavy lifting efficiently and securely behind the scenes. It's the secret to building a powerful and performant app. So let's get building. Let's start by connecting FlutterFlow to our database. I've chosen Supabase for this project, but FlutterFlow supports a number of databases natively. So shout out the database you're keen to see integrated into an upcoming project in the comments. We'll be using Supabase for both its robust PostSQL database as well as for authentication. So let's set both of those up now. Configuring the Supabase backend involves defining the data structure, setting up user authentication, and implementing some security rules. So we'll start off in the dashboard. Let's create a new project and we'll call it the Quiz of Everything. We'll add a database password and choose our region. You might have noticed I am an Australian, so I'm going to choose Southeast Asia, but you should choose the location that is closest to your users and hit Create New Project. The database schema serves as a blueprint for the application's data layer. A well-designed schema dictates how information is organized, stored, related, and accessed. Planning it thoroughly is essential to accommodate what we want to do now and also what you want to achieve in the future. Once you've created your new project, head back to FlutterFlow and into the settings and select Supabase. toggle on Enable Supabase, and you'll see that we require a project URL and an API key. And you'll get those from the dashboard in Supabase. Once you've put those in, select Get Schema. Now, we haven't set up a schema yet, so it's not going to get anything, so we better go and set that up. In your Supabase dashboard, head to Database and Schema Visualizer and create new. The first is Profiles. Now, this is going to store all the public user data and will complement Supabase's built-in authentication. This separation is standard practice in Supabase. It keeps sensitive authentication data private while allowing controlled access to public information. We'll need to set up a few fields. Firstly, ID, which will be a UUID, and that will be our primary key. We'll then also set up username, which will be a text field. We'll set up created at, which will be a timestamp, and default to now. We'll set up an avatar URL, which will be text and nullable. This will store the user's profile picture, which may be implemented later. Hence, we'll set this as nullable initially. Once that's all done, hit Save. Next, we'll set up a table called Quiz Sessions. This will track each instance of a user taking a quiz. So we'll need an ID, which will be our UUID, and our primary key. We'll also set up a user ID, which will be connected to the user's ID in the Profiles table. Using onDelete, set it to null, allowing a topic to be deleted without losing the historical record of the session. The topic ID will simply become null. We'll set up a start time, which will be a timestamp defaulting to now to record the quiz session beginning. And an end time, which will be set as default of null. We'll set up a score, which will be an integer representing the final score achieved for the session. We'll set it as an int8. And then a completed flag, indicating quiz session has been fully completed. It will default to false. Once that's all done, hit Save. The next table we need to set up is Session Answers. This stores the details of each answer given within a specific quiz session. It needs a ID, again, a primary key, consisting of we'll add a session ID, which will be a foreign key, linking to the quiz sessions.id. And on delete, we'll set that to cascade, meaning that if the user's ID is deleted, then all of the user's sessions are also deleted. We'll set up question details, which will be JSON data. Now, we don't entirely know how this will come back yet, but it will store the content of the question asked. We'll use JSONB because it provides some flexibility around accommodating dynamically generated questions. We'll set up user answer, which will be text related to what the user has selected as their answer. We'll set up a flag called isCorrect, a Boolean that will indicate whether the answer the user provided was correct or not. And an answered at timestamp. Which will default to now. With that all done, we'll hit save. So our schema has 3 tables at the moment, and they all rely on clearly defined relationships and constraints. Each table has a primary key, which are UUIDs for globally unique identification. Then we have foreign keys, which establish some links between those tables. We've also got some cascade actions set up, where child records are deleted if the parent record is deleted. And this is important, so if our user deletes their profile, all of their data is also removed. With those 3 tables set up, we can go back to FlutterFlow and hit the Get Schema button, and this will show the schema we've set up. If anything looks wrong, you can come back to the Supabase database and make some edits by hitting the 3 buttons next to the table name in the table editor. Now let's set up Supabase Authentication. Email and password authentication is what we need to start with. It provides a standard, secure method for user registration and login, and it's well integrated into FlutterFlow's built-in actions. There are other methods like Magic Link or social logins, and these exist within Supabase, but email password authentication offers a straightforward starting point. Go to Authentication and then Providers. Locate the Email Provider section and click to enable it. In the Sign In/Up section, make sure to turn off Confirm Email and Secure Email Change, if not immediately needed. This is simply for setup ease. If email verification is a requirement, I'll put a link in the description below to the custom logic that you can implement within FlutterFlow. So a key aspect of Supabase integration involves managing user data across the private auth users table, which is handled by Supabase Auth, and the public profiles table, which we've created in the schema. This separation necessitates a 2-step process during user sign-up within FlutterFlow. The first step is triggering Supabase Create Account authentication. This action interacts with Supabase Auth to create a new user entry in the secure Auth users table using the provided email and password. And the second step, immediately following successful execution, and typically in the same action chain, is triggering the Supabase Insert Row action to insert a new record into the public profiles table. And the ID field of this new profile record should be set to the user ID obtained when creating a new user. Other fields like username can be populated from user input during sign-up, and this ensures that the public profile is correctly linked to the secure authentication record. This two-step process is fundamental because Supabase Auth manages credentials securely and separately from application-specific profile data. Row-level security, or RLS, is a cornerstone of Supabase security, and it's especially important when interacting with client-side applications like FlutterFlow. RLS moves authentication logic from the application layer into the database itself, ensuring that users can only perform select operations on rows they're explicitly permitted to access. It's essential to enable RLS on all tables within exposed schemas, like the public schema that we've got here. Without RLS enabled, the anon key would grant broad access, creating significant security vulnerabilities. You can enable RLS in two ways. The easiest is within the Supabase table editor itself. In the Supabase dashboard, check the Enable Row-Level Security option. You then need to define some RLS policies, which are SQL rules that define access conditions. There are templates here on the right to help you set up the required row-level security policies. Finally, we're ready to set up our UI in FlutterFlow. First things first, let's set up our themes. In Theme Settings, under Color, we can set up and preview our theme colors. Click any of the color swatches to get an immediate preview of what your color scheme could look like in your app. By clicking the Explore tab, you can also explore some of the pre-built themes available in FlutterFlow. Next, head to Typography and confirm your primary and secondary typefaces. I've also included some custom fonts here, which I'll use selectively in the app for effect. So with our color and typography setting complete, let's set up our pages. We've recently made a ton of improvements to our AI page generation. So whenever I'm starting a new project or creating a new page in my project, I always like to give this a quick go. It's a really quick way to get some super interesting results and thought starters. Here, I'm setting up our quiz screen page, the screen that will show the active quiz and display our 4 dynamically loaded questions for the user to click on. There should be a 10-second timer as the time limit to answer each question. Sometimes the best part of AI Page Gen is just getting that base page set up that you can then build on yourself. Okay, so it's set up a basic quiz page. It's not too bad. I'm going to give it a 2. This will form a nice base that we can build upon. So now we'll put a navigate to action. So when the user enters their quiz topic and hits play now, we'll navigate to this quiz page. Now let's use AI Page Gen to create a post-quiz summary of the results the user has achieved in the quiz round. It will show the user's final score, and importantly, if they didn't score more than 2 questions correct, they'll have to retake the level. Otherwise, we'll provide them with an AI-generated list of similar topics adjacent to their original topic for them to build their quiz out upon. This page isn't bad. We'll score it a 3. So this page clearly shows the number of questions the user scored correctly in the latest round. There's a few text color and styling things we might want to have a look at, but it's used the conditional builder to build out our page logic. For this page to display the information it needs, we're going to need to add a couple of page parameters. The first one being the number of correct answers the user scored in the round they've just finished. That will be needed by the conditional builder, as well as our main widget at the top of the screen showing their score. Now let's talk about theme widgets. I'm going to let you in on a little secret. FlutterFlow has a brilliant Theme Widgets section that every app should use. It allows you to define some base characteristics for some key widgets that you're going to use throughout your app. We're going to set up a styled button, a secondary styled button, and a styled text field that we can reapply to those widgets throughout our app and give us beautiful, consistent theming. So the first one I'll create is a styled button. We'll use this button for all the main actions we want our users to take. It'll consist of our primary color and help direct the user through our app in the direction we want them to take. And so I'm going to base the design of this primary button off one of the styles of buttons we've already created. So we come in and select button as the button type and build out as many base characteristics for our button that won't change from button to button. When you see a link icon, if it's unlinked, it means that the value contained in the field will just be to display here in our Theme Widgets section. If you see it linked, it means that the exact wording or value will be inserted onto the button when you assign the theme style. I'll show you how that works in a second. So here we're just going to leave button as the text on the button, but unlink it so that whatever button text we already have on our button, when we assign the theme, will remain on the button. Now let's create our secondary button. So now let's go in and assign that theme to all of the buttons on our various pages. And we do that simply by selecting them under the widget styling in the property panel. It's so quick and easy, and you'll end up with a beautiful, consistent design style throughout your app. Also for consistency here, I'm going to copy our background color from our authorization screen onto our main menu page. Which will help our Play Now button stand out for the user. We just need to correct some of the padding around the buttons on the widget itself. Next up, we have a wild variety of text fields. So let's standardize those around the text field we show on the auth page. And it's the same process. You just go in and recreate the text field in the Theme Widget section, and it follows the same process to apply it. With our theme widgets done, we can now look at building our components. Components are reusable widgets that you design once and then use repeatedly throughout your app. This ensures consistency, reduces errors, and makes app maintenance a breeze. So let's have a think about what custom components we're going to need in our quiz. Certainly here on our quiz page, the multiple choice option seems like an obvious component. So we'll right-click on the container and select Convert to Component. This component will need some parameters. Specifically, it'll need the question text. This is the text for the multiple choice option that the user can select. And we'll also take the opportunity to give it similar properties to the rest of our design system. So things like 12 radius corner on the container and similar coloring. We'll wrap this component in a list view and delete the remaining multiple choice question answers from the page, because we'll use our list view to generate its children dynamically from the questions that come back through from our AI model, which we'll create in the next video. Next, we'll turn our question header into a component. This component will tell the user what question number they're on out of the number of questions that are in this round. It'll also contain a timer widget. So again, we'll need to feed this component some parameters. The question number and the total number of questions that are in the round, which we've got set at 5 at the moment, but could change. So we'll bind those parameters to the text widgets and make sure we give them default values. And a little bit of spacing. Now with the timer widget, it's looking a little bit cut off. Our page gen created it correctly and it set the correct 10-second countdown timer, but it's put it within a column inside a container. So let's just move it inside the container and center the container's child alignment. That'll give us a whole lot more flexibility. Now, it's important to remember with timer widgets that you start them on initialization of the page or component that they're within, and you also need to dispose of them. So here we'll add an onInitialization action and 2 onDispense actions. This is so when the component is removed from the widget tree, for example, your component won't be left with any ongoing processes that are unaccounted for. And we'll give the component a callback for onTimerEnd, because we'll need to update the user interface when the user has run out of time. Next, we've got the question itself, which will look spectacular in our custom font. But actually, given it's just font styling that we want updated in this widget, this is actually better suited as a theme widget. So we'll just create a text theme widget and apply the theme styling to that line of text. We'll make it a maximum of 3 lines and link that value. Then we can apply the styling to the header. The rest of the page will build out once we construct the AI model's response to deliver the quiz for us. Next, on the score widget, we'll convert our score display component that will accept the score as an integer and the number of questions that it's out of. And we'll bind those values to the text widgets inside the component. Finally, let's convert our heading here, the name of our app, into a component, and I'll show you how we're going to reuse it in a really interesting way. So this component is made up of a rich text widget, using our custom font in various sizes and colors. We're going to feed our component the topic that our user has chosen for their quiz, as well as a Boolean to designate if it is expanded or not. When this component exists as the great big quiz of everything on our main page, it will not be expanded, but we'll use an expanded version while our AI is creating the quiz, because we're going to have a bit of a time gap and we want to keep our user interested. So instead of just having a boring loading screen, we're going to turn this component into the great big quiz of the topic that the user has entered. And then we'll bind the component parameter for the topic to our everything widget. And to account for any instances where the user hasn't yet chosen a topic, we'll set the default to be everything. We're also here updating the box shadow and blur to be more prominent if the widget is expanded, and I'll show you why in a second. Now, once the user presses the Play Game button, we'll display a custom dialog with this component inside of it. Expanded to true. And the quiz topic to be equal to the text field value the user has entered for their topic. That should provide a little bit of visual interest while our AI is spinning up our quiz and the audio for our presenter is being created. Now let's set up the navigation and add in some placeholders for the content that will come in the next video, where we have an LLM generating the quiz of everything. So everything kicks off when the user hits the Let's Play button. We've already set up 2 actions in here, but between them, we'll add in a placeholder for an API call. This will be to go away and research the topic that the user has given it, as well as use 11 labs to generate the text-to-speech for our host. Our host is going to read out every question that our user is asked. This backend service will also integrate with Supabase to set up our quiz sessions and our session answers. Once that API call is successful, we'll dismiss our loading dialog and insert a new row in the quiz sessions table. This will just include a few of the fields we know so far. Specifically, we'll set the ID, which we'll get back from our backend API call. For now, we'll assume it'll come from the JSON path of ID. We'll set the user ID from the Supabase authenticated user and the start time to be the current time. We'll give that action output a name of new quiz session. And then when we navigate to the quiz page, it will be the new quiz sessions reference that we'll be passing as a page parameter. Then, as always, should our API call not be successful, we should tell the user. So we'll set a snack bar to say that we were unable to start the quiz. And of course, dismiss the dialog so our user isn't left with an open dialog they can't dismiss. In the next video, I'll show you how you can generate a quiz based on literally any user input. It's an exciting ride into the world of LLMs, so don't miss it. If you've liked this video, please like and subscribe. And I'll see you in the next one.